Hi, snow leopards. Welcome to day 4, chemical reactions. For today, your goal is to go deeper to look at molecular nature of our outputs. What is poop and how is it different than what went in? You should answer the following by the end of the period. Answers in your doodle sheet from M to Q. You're going to need your IOU poster, the input output uses poster. That's the one that you made with your group. And you'll be revising your poster as well as doodle letter C in your doodle sheet. All right, let's get started. So adding to our diagram. Now that we know what food is, right, what it's made of from the Calorie King, let's go back and add that information to our inputs, outputs diagram. Put down the kinds of molecules and the elements they contain, which you have from your doodle sheet. And make alterations. Making sure to add in those carbs, fats, proteins, glucose, CHON, all of those things. All right, do that now and then come back. Now, what about the outputs? Is there anything we need to add at this point? So go ahead and use your group representation and add into the outputs. Carbs, lipids, fats, CHON. Think about what you can do to an output for what you have now. All right, once you've done that, let's go to outputs. So we're going to go a little further in our exploration of the body's outputs. What is pee? What is poop? What is sweat, tears, or other things? What are the other outputs we've maybe forgotten about? Take a moment on your own to write down some of those ideas in Doodle M. Go ahead and put me on pause, and then come back to this. All right, now that you've got that answered on your answer sheet, what is poo? So here we have the digestive system of a chicken. And so you know the food goes into the beak. Chickens are actually omnivores. They eat a little bit of everything, bugs, grubs, worms, as well as grasses, seeds, things in the soil. How do they break their food down, or how do they digest? It goes down their esophagus, just like we have an esophagus. They have some other features in this digestive system that we don't have, like the crop. But basically, it goes through this whole long tubular-like system. Keep in mind, as you come along, we get to this area called the gizzard, which is our stomach, like our stomach. And that is where they break down physically and chemically using enzymes, bacteria, hydrochloric acid is in there to break stuff down. But then once you get into the small intestine, that is where food is more reduced with enzymes, and then it gets passed through and to the rest of the body. Now, not all of the food goes out into the body. This is really a closed system here. It's just this tube that kind of runs from mouth to anus, and a lot of it doesn't leave that tube. So, to recap, digestive systems are just tubes with openings at each end. Food gets digested or broken down, and then nutrients are absorbed into the bloodstream through the walls of tube and then taken out to cells. And if they're not going into the bloodstream, they're coming out like as poop. Okay, let's go into it a little bit deeper. So here we have a model diagram. The brown part represents the organism. You've got the food going in, and so that means that tube must be what? The digestive tube. And so you've got the tube going from one end of the organism to the other. And keep in mind that as the food moves through the organism, some nutrients get absorbed and some waste comes from the body and back into the tube, and then that comes out as feces. Some things might surprise you about it, though, which is poop itself is stuff that we couldn't digest, and so it actually never leaves the tube. What's in it? Well, it's 75% water. Your poop is 75% water, which might be surprising, but if you think of the amount of water that your body is made of, it's not so surprising. Within that 75%, 25% of it, within the last 25%, 30% of that is undigested food. So you got food that goes in that never makes it to your body at all. You've got bacteria. Bacteria, there's enormous colonies and different varieties of species of bacteria um, in your body that go out with the feces as well. And then there's waste that from the body that gets broken down, blood cells and other things that the body puts into the tube and it goes out. Okay, what is pee? So you can see from this diagram that pee is mostly a substance you know, right? So let's do the official term, urine, which is waste filtered from blood by the kidneys. It's mostly made up of urea. And now let's look at the components of urea, which is carbon, oxygen, nitrogen, and hydrogen. So again, we're recognizing these same elements coming back to us. There's also salts in there, about 3%. But the vast majority of your pee is water. Okay? So again, think about these elements and what you can be putting to your diagram. We've got oxygen, hydrogen, carbon, nitrogen. That's making up your urea. And so let's look at adding that in soon. Well, now we have what is sweat. What is sweat? So sweat's pretty interesting here. You've got these eccrine glands, okay? And they are one of the two sweat glands that we have in your body. You can see that there's pores. There's tubular glands right here, right? And this is the layers of skin. So this is the top. Here is the epidermis, your top skin layer, and then the dermis is a deeper skin layer. And you have these tubes, and water basically, it's 95% water, or sorry, 99% water is your sweat, and it also has salt. And the water comes through the tubes and out through the pores. Down here shows a picture of these pores. You have over 5 million sweat glands on your body, and so all over your body, and it's a way for your body to regulate heat. And you also have stress reactions. You sweat when you're feeling nervous or excited and different things. That is part of your sweat also. So again, 99% water and also some salts. What are tears? So what are tears? Tears are pretty cool. So you can see here we have this lacrimal gland, which is a tear-producing gland. That is where your tears are formed, above the outer corner of each of your eyes. You produce a crazy amount of tears every day. So about 5 to 10 ounces. Well, how much is an ounce? Well, if you think about it, there's about 8 ounces of water in a cup. And so 1 cup of water is 8 ounces that you would drink. Well, you produce 5 to 10 every day in this gland. So another function your body is doing. So what's going on? Why all the waterworks? Well, tears provide oxygen and nutrients for your eyes. They remove waste products. They lubricate the eye. They flush out debris and bacteria. You're constantly blinking, and every time you blink, those tears are spreading across the surface to keep your eyes lubricated. And then they drain into this little hole. And so that's a way for your tears to get moved through back into your body. And then surprisingly, that composition of the tear, what are they made of? They are actually have the same kind of composition as saliva. So you've got water, which is the primary ingredient for your tears, as well as oil and mucus. And the thickest, and these nutrients are crucial for your eye. And then that stuff just drains out the air, and it goes through your nasal cavity, or you can swallow them, and they become a part of the nasal fluid. And when you're crying a whole lot, this is actually the reason why your nose runs when you cry, because of that connection there between those cavities. Okay, so again, more water there. So what is up with water? Water is both an input and an output. I want you to look at how do you represent water in your IOU poster, and make or add in your changes for your group poster.